Naming ionic compounds. I'm going to divide this into three categories. Simple ionic compounds, transition metals, and lower p block metals will have their own system of naming, and then also ionic compounds that involve polyatomic ions. First, simple ionic compounds. Name the metal, which will always come first in the compound, then name the nonmetal and change the ending to end in IDE. So again, the periodic table is divided into two categories. Metals are on the left. That does not include hydrogen. It is a nonmetal. And the nonmetals are on the right, metalloids being in between. And zinc is always going to have a 2+ charge. That's something you need to be aware of. And silver is always going to be a 1+ charge. And so think of it as a staircase, 1+, 2+. Aluminum is always a 3+. And then the nonmetals, getting used to the name takes a little bit of practice. Carbon will be carbide, nitrogen is nitride, oxygen is oxide, fluoride, phosphide, sulfide, chloride, selenide, bromide, iodide, and you'll need to get used to those. So again, just name the metal on the left-hand side and then change the nonmetal to end in IDE. So sodium and sulfur becomes sodium sulfide, just changing the ending of sulfur to IDE. Aluminum and bromine becomes aluminum bromide, magnesium and chlorine, magnesium chloride, strontium and oxygen, strontium oxide, zinc and iodine becomes zinc iodide, silver and selenium becomes silver selenide, and aluminum and carbon becomes aluminum carbide. So name the metal, change the second one to end in IDE. In writing the formulas, now you've got to figure out the subscripts of the numbers. Calcium is Ca, oxygen is O. Calcium from the periodic table has got a 2+ charge, oxide's a 2-, so 2 and 2 gives us the same number of positive charges, but I don't want to write 2 and 2 because ionic compounds must always be reduced to the lowest whole number ratio, so we're just going to leave that as CaO. Barium and phosphorus makes barium phosphide. Barium is a 2+ charge. Phosphorus is a 3- as the phosphide ion. And now we're going to switch, so we have the same number of electrons gained as lost, and that makes this compound Ba3P2, barium phosphide. Zinc is a 2+, sulfur is a 2-, and so again, zinc needs to lose 2 electrons, sulfur needs to gain 2, and so that's going to be a 1-to-1 ratio, so zinc sulfide. Silver oxide, symbol for silver, symbol for oxygen. Silver is a 1+ oxidation state or charge. The oxygen is a 2-, so I need 2 silvers for every 1 oxygen, so Ag2O. That way silver gives up 2 electrons, the oxygen gets 2, both get as stable as they can get in terms of electron configuration. Aluminum oxide, symbols are aluminum, Al and O. Aluminum is a 3+, oxygen is a 2-, switch, and it's Al2O3. Looking at the transition metals, these involve multiple oxidation states or multiple charges. Again, that is going to be all lower p block and d block metals, excepting for silver. Silver is always a 1+, zinc is always a 2+, so we don't need the stock system or the Roman numerals for these. So chromium here can be a 2+, 3+, 6+, and so it can combine with chlorine in a 2-to-1 ratio, 3-to-1 ratio, 6-to-1 ratio. I can't name them all just chromium chloride, and so I need a system that's going to designate which of these chromiums is involved in the compound. That is called the stock system. It uses Roman numerals to indicate the charge on the cation. And this is pretty simple. If the manganese has a 2+ charge, we call it manganese 2. If it's got a 3+ charge, it's manganese 3, 4+ manganese 4, 2 plus, iron 2, iron with a 3 plus is iron 3. And so if copper has a 1 plus charge, not too surprisingly, it's copper 1. And if it's a copper with a 2 plus charge, we call it copper 2. So Roman numerals indicate the charge on the cation. When it comes to naming them, then you must figure out what is the charge on that transition metal or lower p block metal. We do that from looking at the negative ion. The chloride ion is a 1 minus ion. If I have 3 of them, I have a total of 3 negatives. Since the whole compound is neutral, that must be a 3 positive. And so we name this compound not just iron chloride. Again, we name the metal, change the non-metal to end in IDE, but this is going to be iron 3 chloride. It's the iron that has a 3 plus charge. Likewise, if we have a chloride with a 1 minus and we have 2 chlorides, so there's 2 negatives, that means that iron must have a 2 positive charge, and that means that is going to be iron 2 chloride. The sulfur has a 2 minus charge. If I have 2 sulfurs, there's 4 negatives, which means this iron must, or lead must be a 4 positive, and so that is lead 4 sulfide. The next one is going to be lead 2 sulfide, because the sulfur again has a 2 minus charge. Therefore, this lead must be a 2 positive, and the compound's formula has been reduced, but it is lead 2 sulfide. Next one, oxygen is a 2 minus, so that is going to make that a manganese 2 oxide. Here the oxygen from the periodic table is a 2 minus. If I have 3 oxygens, there's 6 negatives. If I have 6 negatives, I must have 6 positives. If 2 manganeses are adding up to 6 positives, each must be a 3 positive, so that then is manganese 3 oxide. Again, we don't want to name it manganese 6. You don't want to name it after the charge on each individual manganese, and so that is manganese 3 oxide. Writing the formulas is fairly straightforward. Iron 3 oxide, iron is Fe, oxygen is O. Iron 3 means it has a 3 plus charge. The oxygen is a 2 minus, and then switch, so Fe2O3. Tin 4 fluoride. Tin 4 has a 4 plus charge. Fluorine is a 1 minus, so I need 1 tin 4 ion to 4 fluoride ions. That gives me 4 positives and 4 negatives. Chromium 3 sulfide. Chromium 3's got a 3 plus charge. Sulfur's got a 2 minus, and again, just switch. So we need 2 chromium 3 ions to 3 sulfide ions. So Cr2s3. Copper 1 bromide is just going to be CuBr, because copper 1's got a 1 plus charge. Bromide's got a 1 minus. Cobalt 2 nitride, so cobalt and nitrogen. Cobalt 2's got a 2 plus charge, nitrogen's got a 3 minus, and again switch, and so it is going to be CO3N2, and manganese 4 selenide. So again, write the symbols down, figure out the charges on the cation and the anion, cation from the Roman numeral, anion from its position on the periodic table, switch. Only this time we don't want to write 2 and 4. Again, ionic compounds must be reduced to their lowest whole number ratio, so that is the correct formula for manganese 4 selenide. Last category is going to be polyatomic ions. These are sometimes called tertiary compounds because now they've got 3 elements such as calcium, carbon, and oxygen. And polyatomic ions are just groups of atoms that are covalently bonded that collectively have gained or lost electrons. And so they can have a 1 minus charge such as the acetate, or the hydrogen carbonate or bicarbonate, the nitrite, nitrate, and so on. You'll have a table like this to refer to when naming these compounds. And so calcium carbonate is CaCO3. We know the calcium from the periodic table, and the carbonate polyatomic ion is the CO3 2- ion. So that gives me the compound calcium carbonate. Okay, next one we have aluminum and the hydroxide ions. Again, on the polyatomic ion table, find the OH- ion. That is the hydroxide ion. And so this compound is made up of the aluminum and the hydroxide, aluminum hydroxide. Next one, this is the sodium, and this from your polyatomic ion table is the hydrogen carbonate or bicarbonate polyatomic ion. So the name of that compound is sodium hydrogen carbonate or sodium bicarbonate. The next one we have iron and the nitrate polyatomic ion. So here is the nitrate polyatomic ion. It's got a 1- charge. And if there are 3 nitrates, 3 1- attached to the iron, that then is going to be iron 3 nitrate. This is the copper ion. This is the chlorate ion. The chlorate ion has a 1- charge. And if the chlorate ion has a 1- charge, that means this copper must be a 1+, and so that is copper 1 chlorate. The next one is made up of 2 polyatomic ions. This is the ammonium polyatomic ion. This is the cyanide polyatomic ion. So again, there's 1 positive polyatomic ion, the ammonium, and here's the cyanide polyatomic ion, and put them together makes the name of that compound ammonium cyanide. And the last one, we have a magnesium and a phosphate, and so that is magnesium phosphate. Last thing, how do I write the formulas for these compounds? So if I want to write the formula for ammonium phosphate, go to the table of polyatomic ions, find the ammonium ion, find the phosphate ion. The ammonium ion is a 1+, the phosphate is a 3-, and so I need 3 ammoniums to 1 phosphate. Anytime I need more than one of a polyatomic ion, I need to put it in parentheses. So the ammonium is the NH4. I need 3 ammoniums, 3 NH4s with the 1 phosphate. Aluminum nitrate, again, write the symbol for each. Aluminum is a 3+ charge. Nitrate is a 1-. Find that on the table. And then switch, I need 1 aluminum to 3 nitrates. Again, the NO3 is 1 nitrate. I need 3 nitrates, so I have 3 negatives to balance the 3 positives. Manganese 2 hydroxide. Manganese is Mn. Hydroxide from the polyatomic ion table is the OH- polyatomic ion. The manganese is a 2+, hydroxide's a 1-, so I need 1 manganese to 2 hydroxides. Again, the hydroxide's a polyatomic ion. I need more than 1, so I have to put that in parentheses and put the 2 on the outside, so that gives me 2 hydroxides. Tin 4 phosphate, symbol for tin is SN, phosphate is PO4. Tin 4 has a 4+ charge. Phosphate has a 3-. Switch. I need 3 tin 4 ions and 4 phosphates. 3 tin 4s will give me 12 positives. 4 phosphates will give me 12 negatives, so I have the same number of electrons gained as lost. Next one, ammonium is a polyatomic ion. The hydrogen carbonate is a polyatomic ion. And so here's the ammonium ion. It's positive, so we'll write that first. Here's the hydrogen carbonate polyatomic ion. So we're just going to put those two together, and it is ammonium hydrogen carbonate. This is a 1 plus. All of this is a 1 minus, so it is just 1 ammonium to 1 hydrogen carbonate. Chromium 3 sulfate. Again, write the symbol for each. The sulfate is a polyatomic ion. SO4, chromium 3 has a 3 plus charge. From the polyatomic ion table, the sulfate is a 2 minus charge. And then switch, I need 2 chromium 3s to 3 sulfates. Anytime I need more than one of a polyatomic ion, I must put it in parentheses. And that gives me the formula for chromium 3 sulfate.